A special case arises when one denominator is the opposite of the other when you're adding or subtracting rational expressions. When this occurs, we can multiply either expression by 1 using -1 over -1. And in this first example, very close with our common denominator, except they're opposites of one another. To fix that, I'm going to multiply the second rational expression by -1 over -1, which itself is equal to 1. But if I do the multiplication, the first fraction will stay the same. The second fraction will result in a product of -1 in the numerator, a negative times a negative in the denominator, and 6x times 1 is 6x. I now have a common denominator, which means I can go ahead and combine the numerators. 5 plus a -1 is 4 over 6x, and always look to see if we can simplify further. There is a common 2 in the numerator and the denominator. 6 divided by 2 leaves a 3 for a final simplified answer to this sum of rational numbers of 2 over 3x. Here, instead of a monomial, we have a binomial as our denominator, and these are opposites of one another. We can use that same technique of multiplying by -1 over -1 to change those signs. The first fraction or rational expression is unchanged. We have a subtraction here. Subtraction is the same as plus a negative. So when we perform the multiplication, a -3 times a -1 in the numerator results in 3. The denominator will distribute that -1 across each term, resulting in a -7, and a -1 times -x is a positive x. These are the same, but just to show, using commutative property, that they are in fact the same, I'll rewrite the denominator of this second rational expression, putting the x in front and the -7 behind it because of commutative property holding for addition. Clearly, we do have common denominators. We can go ahead and combine our numerators then. X plus 4 plus 3 results in an x plus 7 over x minus 7. These are not common factors, so this is simplified. In this next rational expression that has addition in it, we need to find what that common factor is so that we can add these two rational numbers together. Factoring the denominator, we have an x minus 5 times the binomial x plus 2. And if we look at this second rational expression, the denominator is the opposite of this factor in the first rational expression. So we can fix that by multiplying top and bottom by the -1. And furthermore, once we have that fixed, the only factor that's missing for the least common denominator in this second rational expression is an x plus 2. So we'll throw on a third multiplication here, leaving that first rational expression as is because it has the desired common denominator. Simplifying the multiplication next, multiplying 2 times -1 leads to a -2 that we then will distribute that product. -2 times x will give us a -2x, and -2 times 2 is a -4. In the denominator, multiplying these three things, I'm going to take the -1 times this binomial, which leads a negative on our 5 and a positive on our x, which is x minus 5. Mission accomplished there. And then instead of multiplying it out, because we'll need it in factored form to determine whether it's simplified, we'll just write the x plus 2. Mission accomplished as far as common denominators. We can then go ahead and combine our numerators by adding like terms. X plus negative 2x leaves negative x. 3 plus negative 4 is negative 1 over that common denominator of x minus 5 and x plus 2. The quantity in the numerator is not the same as either one of the factors in the denominator. We're done unless having the leading coefficient a negative 1 is bothersome. We can factor out a negative 1 from the two terms in the numerator and express it as negative 1 times the quantity x plus 1 over that common denominator, which again is just an equivalent form, but nothing can be canceled as we previously decided.